Expand this bracket and that bracket up to x cubed, giving the valid range. So we can choose to do it by partial fractions, or we can just use the binomial series and just do the expand the bracket of the resulting binomial series. My preference, I think, would be just to do it by binomial series. Probably might be slightly harder, but I just prefer that method. So here, what have we got then? We've got 1 minus 2x. I'm going to write this term first because it's easier to do. 1 plus x to the minus 1 will be 1 minus x, we know this one, plus x squared, minus x cubed plus dot dot dot. That's that standard series there. This one here is a minus 1 over 1 minus x, so it's, but instead of x we've got 2x, so remember it's 1 plus x squared plus x cubed, but our input is 2x here, so it's 1 plus 2x, plus the 2x squared would be 4x squared, wouldn't it, and then plus another 2x bracket cubed would be 8x cubed, 2x times 2x times 2x. So there's that series. So all we now need to do is it's 1 times all of these. We need to go up to the x cubed, so it's one of those. And then it's plus dot dot dot, minus x times all of these, so it's minus x, minus 2x squared, minus 4x cubed, and so on, plus x squared times all of these, plus 2x cubed then, x squared times that would be 2x cubed, and then we're done. And then the last term x cubed, it would just be x cubed times 1, which is minus x cubed. So there's our 4 expansions. So it was 1 of all these, which we put here, minus x of all these, which we only needed to go up to the x squared, minus x of 1, minus x of 2x, minus x of 4x squared, and you write that down. Then you do the x squareds, so it would be plus x squared, 2x cubed, and x squared plus 2x cubed plus, that's it. And then the x cubed is just the one term. So if we arrange it like that, it's easy to write down now. So what have we got? We've got 1. We got 2 take 1x is plus x. 4 take 5, 3 x squared. 8, 10 take 5 is 5 x cubes. They're all pluses, so we can just write it carries on. The valid range here, the range, as far as the range is concerned, minus 2x, modulus is less than 1, and the other range would be x is less than 1. Here's our valid range that we've mentioned. So this just implies that 2x must lie between 1 and minus 1, and that tells us that x must lie between, divide by 2, a half and minus a half. And this one tells us that x must lie between 1 and minus 1. So for them both to be satisfied, the smaller one that sits inside the larger one suffices for the range in question. So we can write that down explicitly.